All right, guys. Hey, long time no see. So we are going to continue on with chapter 12. If you do not have the notes there at home, then you can go into Files in eCampus and go to Notes, and you should be able to find the chapter 12 notes there. So we left off on section 4. We are continuing on with section 5. So 12.5, we're going to be dealing with just to go over some vocab here. Remember that we have a tangent line, which only touches the circle in one spot. We also have something called a secant line. Ooh, that was not pretty. That hits the circle in two different spots, but continues on forever. So when we have one tangent and one secant, we know that the angle formed right here is going to be half of this this arc that is between the two lines. Okay, so we are going to say if a tangent and a secant, or chord, intersect on a circle at the point of tangency, then the measure of the angle formed is half the measure of its intercepted arc. So, number one, we are trying to find the measure of FGH, which is this guy right here. So since we have a tangent and a secant forming that angle, we can look at the arc up here. So the angle that's formed is going to be exactly half of the measure of that arc. So the measure of angle, FGH, is going to be equal to half of 216, which is going to be equal to 108 degrees. Okay, so now moving on to question 2. Now this time they gave us that angle, and they're asking us to find the measure of this arc. So we know that the arc is the bigger of the two. So the measure of arc LM is going to be double the angle, which will give us 128 degrees. Okay, for the next one, if two secants or chords intersect in the interior of a circle, meaning that we're looking at that point right here at 1, or at E rather, then the measure of the angle formed is half the sum of the measures of its intercepted arcs. So all we're doing here is we're finding the average of these two arcs, and that will be equal to this angle. And since they're vertical angles, it would also be equal to that angle. Okay, so we are looking for JML, which is this one right here. So we are going to say that the measure of angle JML is, we need to do the average, so we're going to add 70 and 52 and divide it by 2, or 1/2 of 70 plus 52. So 70 plus 52 gives us 122. And then 122 divided by 2 is 61 degrees. So that angle is 61 degrees, and so is this one, 61 degrees. Okay, in this one we are trying to find the value of x, which we are going to assume they're talking about this right here for our x. So we know that if we add 104 and x together, and we divide by 2, we are going to get 68, right? Because both of these angles have to be 68 degrees, and it's the average of the two arcs. So we're trying to solve for x. So we first need to get rid of the part that is being divided by 2. So we're going to multiply by 2 on both sides. Okay, and we are going to get 136. 8 plus 8 is 16. 6 times 2 is 12 plus 1 is 13. Yeah, that's fine. 136 equals, these canceled out. So we have 104 plus x. We now can subtract 104 on each side of the equal sign, which means we're going to be left with an x on this side. And on the other side, 6 minus 4 is 2. 3 minus 0 is 3. And 1 minus 1 is 0. So x is equal to 32 degrees. And our, I believe, last section, last little part. So in this one, this is when we have two segments that intersect. So it could be a tangent and a secant. It could be two tangents. It could be two secants, but they intersect on the outside of the circle. Okay, so when that's the case, we are going to, instead of adding the two arcs and dividing by 2, we are going to subtract the two arcs and divide by 2. So we are doing half of the difference of the measures of the intercepted arcs. So in number 5, this angle, x, is going to be the difference of the two. So this one here, the 140 minus the 74, 140 minus 74, and we are going to divide by 2 from there. So 140 divided by 74, I don't have my calculator on me. 7, 8, 9, 10, 11, 12, 13. Yes, I just counted on my fingers. That is fine. Okay, so we're going to get 66 divided by 2. And then 66 divided by 2 is 33. So that angle is 33 degrees. This one. Oh, interesting. Okay. So it didn't give us this arc right here, but we can figure it out, right? So if the other arc, this one out here, is 232 degrees, and we're actually looking at the entire circle right here, we can actually do 360 minus 232. 232. And we can get 128 as our other angle. Okay, so that value x is again going to be the difference between those two arcs. So we're going to subtract them. 232 minus 128. And then we're going to divide that by 2. So 232 minus 128. 2, 12, 8, 9, 10, 11, 12. 2 minus 2 is 0. 2 minus 1 is 1. So this is going to be 104 divided by 2. And 104 divided by 2 is 52 degrees. And our last one. So in this one, the x is in a different place, but that doesn't matter. It's okay. So when we subtract the arcs, here's the bigger arc minus the smaller arc. So 108 minus x if we cut that in half, it will be equal to our angle, which is 35 degrees. Okay, so now all we're doing is solving for x, so we need to multiply by 2 on both sides, and we will get 70 is equal to, these cancel, 108 minus x. And what I'm actually going to do here, because I don't want my x to be negative, I'm actually going to add x to both sides, which is just going to put x, it's just going to move it, it's not actually combining with the 70. And now, since that cancels, now I can actually subtract 70 on both sides, which means that I will get x equals, oh, I don't know why I did all that. 8 minus 0 is 8, and then 10 minus 7 is 3. So x is equal to 38 degrees.